Hello everyone, this is Garrick Labra. Today is July 18th, 2021. I'm a UC Davis undergrad, neurobiology, club director of Neuropower. I'm here today to dissect a sheep or pig brain, I'm not sure. I ordered a set of 3 brains off of Biology Corporation, yes that's a real corporation, based out of Minnesota. They are a educational products company that provides specimens for biology classes. So I bought a set of 3, a cow, a pig, and a sheep brain for $40. They arrived a couple days ago. I have set up my lab here at home. I wiped down my countertop with Clorox. I put down aluminum foil everywhere that I use to collect any formaldehyde that has been coating the brain. That is the fixative that was used on the organic material. I also am ventilating my lab area. That back door is open so air can move in and out. And I also have a fan running overhead with extra light to help with the video. I do not have an actual dissection kit, but this should also work out fine because I still have various cutting, probing tools. As far as PPE, personal protection, I have these latex gloves. I additionally have a KN95 mask. For what I'm wearing, following standard procedure, as according to all chemistry classes, I need to wear not a button-down shirt, but I need to wear a cotton shirt. It's buttoned all the way down. That at least covers up to my wrists. You cannot be made out of plastic or polyester, because if it is, then it will melt if it were to catch fire. Unfortunately, I don't have a lab coat, so I'll have to use one of my old crumply dress shirts. And then finally, to protect my eyes, I will be wearing these safety glasses to make sure I do not get any formaldehyde in my eyes. Now, the reason why we care about this is because formaldehyde on its own, CH2O, will react with any water to create formalin, and will act as a fixing agent and will start to form a film. Now, this is caustic. It is not corrosive, but it is very toxic to living beings. Luckily, everything we're working on is already dead, so we don't have to worry about that. But to protect ourselves, we always have to make sure not to get any of the formaldehyde in our eyes or in our mouth. The products I've ordered came with this mammalian brain manual. Now, the manual has a couple of typos. It has a couple of false facts. It was written by Lisa K. Hiat, and it comes from Nevada Street, Alexandria, Minnesota, biologyproducts.com, Biocorporations Incorporated. It comes with illustrations. It covers most of the tissues that we will find in this brain and is a good start to our dissections, not just for you, but also for me. We will follow this manual and identify all the bits and pieces, and eventually we will do the cutting as well. Now, the products which I've ordered, they do have the meninges on them. We'll point out the dura mater, and I'll try to also identify the pia. The arachnoid is beyond recovery. I believe that because the CNS was drained due to the opening of the dura mater, that due to the fragility of the arachnoid matter, there is no artifacts or residuals of the arachnoid space, or the arachnoid structures. So unfortunately, we can't really look at that. All of the black spots you'll see will be capillary structures, capillaries, veins, and arteries. So the cuts have also been from the brain, or sort of at the brainstem. Hopefully we can also identify the cranial nerves, not just the optic olfactory bulb or the the vagal nerve, but also the ocular motor nerves and everything else that is particularly on the medulla oblongata. I watched some other dissection videos and they appear to be very hard to find. I will try to mark them with this Sharpie. Now, the reason why I'm marking with a Sharpie is to blacken them and to make them more identifiable or seeable. I'm not too worried about getting formaldehyde on a Sharpie because I'm never going to put it in my mouth. And additionally, being in such small quantities, I'm just not worried. Oh, right. So I do not have a dissection kit. I've also removed all of my foodstuffs from the room, as you should. You should never have any food or drink in the laboratory. You should always, if you're going to need to consume something, have some water. Always do it outside of your working area. Now, because I don't have it as a dissection kit, I do have my woodworking tools and my chisels. So, instead of a probing tool, I'll be using this chisel, and instead of a scalpel, I'll have this flex cut straight edge. If I need any more, I do also have a crescent knife in my back cabinet there, so I'll go get it as needed. So, let me put on my gloves and let's open up this puppy and blow my nose. Oh, finally, also to identify different areas, I will be using these sticks. Now, I like to light incense around the house or outside. Well, I never light incense in the house because then you get the smoke all in the house. I do it outside. But incense sticks sometimes have colored tips on the stick end. So what I would suggest, if you have incense or you have any other colored sticks, cut off the colored part, and then you can use that as your own identifying sticks by pushing it into the fascia. So now, I also have, also in case there's any extra water residual onto the specimen, I'll be using paper towels, and I'll dispose that with all my other materials to the proper authorities. So with all that done, let's get started. Goggles. As you can see, it's very wet but vacuum sealed. That's probably not CNS, that's probably the formalin or formaldehyde. But I think I just kind of realized today about CNS is that it never pumps. It doesn't move on its own. Sure, it jiggles, but it is created and does not have its own methods of traffic. Alright, I guess I'll be using this bag to store all my gunky gunks. Okay, oh, that's wet and cold. I've been keeping this in my own fridge. Well, not my food fridge. I bought a mini fridge for this. Don't ever put your specimens next to your food. Don't. Okay, as you can see, we have the dura mater here. It's covering everything except for from the book. We might have to remove these bits, but hey, a little bit of adventure, isn't it? Additionally, the dura mater appears to go all the way to the brainstem back here. We have the medulla oblongata, and then I can't tell if I think the pons is okay. What was it? What was the medulla? No, the medulla oblongata. And then there's another bit. Let's open up the book and actually just get started. So we have the forebrain, the midbrain, the hindbrain. The forebrain is usually the neocortex and all this bit here. The midbrain is more underneath the neocortex and includes some of the brainstem bit on the top. And then there's the hindbrain, which usually consists of the pons and the lower part of the brainstem, such as the medulla oblongata, and just the regular medulla. So, according to this, the forebrain consists of the telencephalon and the diencephalon. The telencephalon contains the cerebral cortex, yes, the rhinencephalon, and the olfactory bulb. If this is the pig, I would guess that these are the olfactory bulbs. Given how strong a pig's nose is, it would make sense they would have such a large bulb. It is amazing that this brain is so small compared to the pig's head that you would usually find. But also remember there is no bone inside of it, and there's also the whole skull. So there may not be enough room. Let's just pat this down to pick up all that moisture, just so I don't have to keep it wet in my hands. Every time I touch this, give it a good little dabby do. Now, this dabbing won't damage anything as long as you are careful and soft. And if I'm not, well, we have 2 other brains to work with, huh? Alright, well, that's neat. This part comes apart pretty easily. It's look like I can just tear it off, but let's not do that quite yet. I think, oh, there's still bone here. I think. Right there. Yep, that's hard. I can't tell those are the nasal cavities, but what else could they be? So close to the brain, especially to its ventral. All right, so dissection, blunt probe, sharp probe, scissors. So when handling a blade, always wear protective gloves. So the first thing you want to do is the cerebrum, and then we also want to do the olfactory bulb and meninges. Well, technically these are the meninges. Meninges are 3 layers: the dura mater, the arachnoid mater, and the pia mater. The arachnoid matter is in between the dura and the pia. The dura is the top part. It's the covering of this brain itself before you reach the gyri and sulci. Then you also want to do the optic nerves, optic chiasma, pituitary gland, capillary beds, pons, cerebellum, and spinal cord. Alright, so let's try to identify all of those. I'm going to first start by moving the meninges. See if since there is no cerebral spinal fluid in here, I want to see if they already made a cut and open that up some more. I believe this might be a cranial nerve right there. Just let's dye that a bit. I'm touching it right now. Let's not keep touching. Let's see if I can get it closer. There. It may be, but let's save that for later. We're now going to cut open the dura mater because I cannot see a good incision. You always want to pinch it, find an air pocket, cut that, not the actual brain itself. Let's see, is there a good pocket anywhere, any bit of flab? I think this is the best air pocket. Luckily, flex cut makes very sharp knives for wood. If it's sharp enough to cut wood, it's sharp enough to probably cut dura mater. Although up here it is a lot easier. Oh, I think I found a fold. Oh, can cut. Oh yeah, I found the cut. Oh yeah, there it is. There are these 2 striations up here. Nope, those aren't tubes, I think. Okay, just keep on cutting that. I believe this is an artery right there, the black part. There we go. Okay, we finally get some pink. Okay, keep on coming off, keep on coming off. There we go, there we go. It's a bit like plastic, to give you an idea of how strong this Dura matter is. Though it looks like old wrinkly skin, type you'd see after you're getting a sunburn. It's just as clear, owning up to the fact that the Dura matter is made out of cells. They're not made of axons. Sorry, they're not made of they're not made out of neurons. The rest of the brain is. Additionally, the Dura matter is not the blood-brain barrier. It serves as an addition to the blood-brain barrier, but it's not the blood-brain barrier in its entirety. We'll just keep on cutting off bits and pieces, try to open up more points of attack. There is a connection here in the center of the brain that's keeping the Dura matter on there. Let's see. See, when you continue to notice the meninges, there's just the list at the matter. You need to remove the meninges to begin the dissection. Follow figure 3. It says, okay, figure 3 shows cut from here all the way to the back in a single line. Let's see if we can do that without damaging. Okay, getting closer. And closer. There we go. There we go. I'm gonna guess that's not all my fault. Since I still have bone, that's part of my brain. I did not order a skull. There is some of it still attached to this nostril part, which is to give you some idea of how far the Dura matter goes, or its connection points. Perhaps that's why they left it as part of the product. The cartilage, sorry, not the bone, the cartilage. Let's keep on removing your suit, dear sir. I wonder if sometimes if this is similar to the pericardial sac, but as you can see, it easily peels off. There's barely any connections between the Dura matter and the pia matter here. Everything on top here is the pia matter. Technically, so is all of these black lines where the arterioles and the ventrioles are. You can't see calipers because the two is small and technically should be inside of the tissue itself. So you can't see it because it's obscured. Additionally, notice how neurons are not clear. That is not a product of the formalin or the formaldehyde. It is not translucent or yeah. Let's keep on cutting it away bit by bit. Better. Okay. I think that's enough. wonder, this back bit here is tougher. Okay. We need to take care to cut around the pituitary gland and optic nerves. Oh, I did get the right thing. What I'm touching, 12 leads back to the eye. Oh, these are eyes. Huh. Too bad they don't have to give good instructions how to cut it, but cut around the pituitary gland and optic nerves. Okay. Meninges only. There is, I want to say callousing, but there's this extra bit right here. I think that would connect to a bone or other bits of the skull. Right here, it just gets thicker, the dura mater. Observations. That is what a lot of science is. And that's the reason why I'm doing this. Okay, that's good. Ugh. Okay, let's do the other side now. Well, let's see. We're already underneath here. Let's see if we can cut it off. So keep it in place. It's actually connected to the cartilage. Interesting. Let's just keep on cutting it there, there. That's about where I cut. Let's keep on just lightly. If you just pull it apart, then you don't need to cut it, but if you have to cut it, then you cut it. So I felt it tug around here. More tugs there. This video is for everyone, not just me. Luckily, there'll be less talking. Next time I upload the video, I'll just skip removing the matter, because it don't matter. Still here. All these creases. Oh, is that bone? Or cartilage? Might be. I do not know what formalin does to cartilage. There we go. Just pull it up and cut at the connection. Makes it way easier. There we go. Ugh. Okay, let's look what's here. More connections. Right there. Just cut it. Let's see if we can find it on the other side and present it to you. Not likely. Okay, let's see if we can just yank this thing back. No, I need to do some more cutting. But I can cut off bits of here off. Be sure not to cut your own glove. Oh yeah, that's cartilage. Man, this is what you have to go through every day through experiments. Just keep that in mind. Okay, you know what? Let's try to do some identification. We got a lot exposed here. Now, if you remember anatomy, you always do directions from the point of the specimen. Their eyes would be about here, their nose there. This is dorsal, it's about where their skull would be pointing up, at the top of their head. Rostral caudal. Left, right. Coronal. Transverse. Medial. This is the longitudinal cerebral fissure right there. This is the left hemisphere, right hemisphere. So don't think lobes, just think hemispheres. Hang on. Okay, back to work. There's some tubing back here. If you remember how a baby gestates, they have the neural tube. I believe this is what that is. Recording! Okay. Right in the back there. Let's see if we can get it closer. Yeah. Yeah, right there. The neural crest. More of that's some form of vertebrae. It's definitely not, let's see, it's 6 here. It's not the cerebellum. Cerebellum, not medulla, cerebellum. Misbellum. Okay. So I have to remove this somehow without destroying everything. Let's see if I can just yank it out. It's coming a little bit loose. Kind of like how you remove a shrimp. Other parts of it, not so much. There's some fat here, I can just pull off. Hopefully I'm not pulling off the pawns or something. Because I believe this is still above the door matter. Got a hold cut. Tug and cut if possible. The easiest means of extraction. I think there's more just the sheathing, yeah. Okay. There we go. Beautiful. Now, like I said, hopefully it didn't cut something important. Looking at the manual, it looks like I did the right thing. There's still a lot of connections. Hopefully those aren't the cranial nerves I'm cutting off exactly. I'll tell you, this thing's a slippery bastard. Okay, we got a purple hole at entrance. Still more coverings. I think that might be the arachnoid matter right there. A little sheen. Right there, yeah. You see the light shining on it? The reflection. What if what's the guy? H.R. Geiger got the idea for some of his art by doing all his dissections. One of the things artists had to do back in the day, back in Resonance, was do autopsies and study the human body after death. If I remember correctly, didn't Leonardo da Vinci have a couple of bodies in the back of his workshop? Let's see what exactly I'm cutting. Okay, so it looks like more cartilage. and some more arterioles and whatever. There's something asynchronous. You got some more cartilage, or what is that? They're keeping it there. I think those are the cranial nerves. Right there. Or that might be the optics. Okay, the trigeminal nerve is what that is. And I think what's supposed to be behind it right there is the facial nerve. So it sticks way the fuck out. Then we have this little nodule right there. Let's study that more later. But first we still have to get rid of all of this gunk on top. Nodule, trigeminal, facial, and there should be one behind it. It won't say. Because I do know the optics are up in front here. Number 6 right there, that's the pituitary gland. Then here and here, those are the capillary beds. Okay. We know this is the spinal cord. Spinal cord. And then up in front, we have the pons up here, because that's right behind the capillary beds. Pituitary gland, pons, and down here we have something else. That might be the medulla oblongata, because right underneath the pons is medulla oblongata, and the medulla oblongata is right beneath the cerebellum, right? Medulla oblongata, cerebellum is up right here. These are still leading back to the eye. This around here is the optic nerve. Optic nerve. Right there. Excuse me. Alright, solved the wardrobe malfunction, and I've had a bit of a water break. Let's get back to it. I'm trying to remove this back bit here. I can't tell if it's actual bone or cartilage. I will do investigations after this video to find out what it is. Let's try to identify some other things since we're here. This is the longitudinal cerebral fissure. All these black lines are sulci. They are the dirges. They are the etchings upon the brain. Now, supposedly, they're supposed to increase surface area for cerebral spinal fluid, also for communication. However, it can also be an entranceway for different blood vessels. As you can see, most sulci are filled with black lines, which are the arterioles and ventrioles. The gyri are the bits that stick out. Let's see if I can point it out better. Gyri, sulci. So when somebody tells you gyrus, they mean bit that sticks out. Let's see if I can find a gyrus here, well, not exactly, but I do know that on the regular human brain, there is I believe there's a temporal lobe here, what I'm supposed to stick out here, that it is a gyrus, and within it contains the central auditory cortex. The central auditory cortex is within the sulci of the temporal lobe, and you have to kind of like pry it open to see it. Okay, what else can we see here? So left hemisphere, right hemisphere, longitudinal fissure, sulci, gyri, cerebellum. Cerebellum is the back part here that's still covered. We have the spinal cord. We have the medulla oblongata, which is again just hidden. We have the optic nerve, which I believe is what's holding this. Let me try and touch it up for you. It is right there, right where I'm touching it. I'm going to try and not cut it, but rather preserve it. As far as what's back here, I'm not sure. But there is parts of it back here that are connecting it. Maybe in sheep no, that gives me the optic chiasm right there. Let's see. Right there. Okay. And then, what else do we got? We get the facial trigeminal nerve, the optic nerve, and then the leads back to the eye. Then the capillary beds, we found the pons serratus, cerebellum, and the spinal cord. So far we covered two figures, figures 3 and 4. The two left cerebellum divided into left and right hemispheres. In humans, the book says that the right side of the cerebral hemisphere is the place where we have creativity, art, emotion, all of that. Everything that is characteristic. On the left is computing, it is law and mathematical. That is false. There are multiple studies that actually debunk this myth. So for the rest of this video, I'm going to keep on providing commentary as I remove the rest of this dura mater. There we are. There's the silver barrel. Nice to see you. Fortunately, I think I might have destroyed bits of it. Yeah, right there. I think that's where my knife went. Unfortunate, but we still persevere. Now, when you're wearing working in an actual lab, you cannot afford to destroy material. That is why I'm doing this on my own time, outside of a lab, outside of a research lab to be specific. Because a loss of material would destroy a research project. Or it's more specifically the destruction of the destruction of tissue. More connector. Right there, right where my blade's about to cut. Right here. Very deep crevice. Trying to angle it to the camera correctly. Right there. And it's cut. Okay. It's amazing how many little cables are used to keep this in place. I think this is the rhino lobe here. It's extremely soft and delicate. Apparently my knife has been making little jabs into this thing while I've been cutting at the dura mater, more so than this bit. Something to pay attention to. Do not forget you're trying to move the dura mater, not everything else from the neocortex or the cerebellum. Hopefully you can find out what the neocortex is compared to the cerebellum, or if they're the same thing. Oh, now this is interesting. This spike right here, if I lift it up, you can see something. My light's a bit too bright. Funny, right? I think that's another nerve connection or nucleus right there below my blade. To what, I'm not sure. Could be, it's leading up to the ocular, so it could be the ocular motor nerve. I'll take a guess and say that's it. Now, I said I was going to dispose or store the main brain bits in formalin. However, for all these other bits, the dura mater for example, I do not wish to store them. They look like trash. And so I will have to speak to the proper authorities still. There is no getting away taking care of your garbage. Okay. A little bit further, a little bit more off. I'm still curious as where it is that I'm cutting apart from. Let's see if I can tear the fissure a little bit. I would need a knife for it, that's for sure, to separate the corpus callosum. There's definitely still a bone here. And then we're going to leave it there. It's not doing any harm. You got the bellum, the pons, the medulla oblongata, the spinal cord. We got all the bits we need to continue next time. But for shits and giggles, let's try to remove these nasals. As you can see here, we just accidentally tore off the olfactory bulbs, I believe. There's a lot of vasculature around these bulbs. Don't forget, some cultures eat this stuff. Without the formalin, of course. But they will boil pig's head. Or, wasn't it used to be a culinary thing? I forget. Yeah, that's a lot of cartilage. A lot of tubing too. Look at that. Look at how it separates. Those are bone structures, given how hard they are, or they could be cartilage. It's not white, but it feels as hard as mineral deposit, but also it's slippery. I doubt it's the formaldehyde because or it could be the formaldehyde, but with different tissue. I need more experience with somebody to consult. I'm rethinking that these aren't nasal passages. Maybe this one at the top here. Perhaps this is teeth? Cuspid? Perhaps? Let's see if we can remove the rest of it over here. It is extremely fragile. Yeah. It could also be a gland because, okay, hang on, let me just remove this a bit more. Because it's in its own chamber, its own camera. Okay, see what I mean? Here. It is sealed. It's a pocket. It's a lumen. And it is right in between the eyes. So I call those the factory bulbs. And they're so squishy. Look at that. Alright guys, that's all for today. This video is about an hour long. I'm not going to edit it. Try to watch at double speed. Those sponsorships from the Biology Corporation. This is Garrett Calabra, Director of Neuropower. I hope you enjoyed the video. Maybe uploading to YouTube, or but I will definitely upload this to Neuropower itself. Thank you for watching. And hey, have some dinner. Have some steak or something. Have some spaghetti. Definitely won't smell like formaldehyde.